welcome to another one of Sybil's teacher tip videos. Today we are going to focus on our 8th grade chemistry student activity pack. Our first activity is called Physical and Chemical Changes. Students will need to take out their small plastic cups, their steel wool, they will want to get a pair of scissors, and then they will also need 4 different liquids. They are going to need vinegar, they're going to need vegetable oil, water, and a clear soda. The clear soda is important so that way they can observe and see if any changes occur. So let's get started. For the first part, we're just going to look at iron and water. So they're going to take their steel wool and we're going to cut it into 8 equal pieces. For this first part, they're going to use 2 pieces and they'll use the other for the second part. So we're going to get 8 equal pieces here. As you can see, it's really easy to cut through the steel wool, so students shouldn't have any issue with that. I say that, and then I get stuck. All right, so they are going to take 2 pieces of steel wool, and they are going to take 2 of their small cups. Now, in one of the cups, they are going to measure out 60 mLs of water, so that's 2 of their medicine cups. 1 and 2. Okay. They're going to take a piece of steel wool, put it in the water, and a piece of steel wool and put it in the empty cup. They're going to let this sit for 24 hours. Come back and record their observations. On their student activity sheet, at the bottom, you're going to see a little description about what's happening, what's going on. We start to talk about physical and chemical changes. The students can then go back, look at their wool, and start to determine what physical changes are they seeing, what chemical changes are they seeing. Part 2 of this activity is looking at steel and other liquids. So for this, you're going to want to have 4 small cups, and we're going to label them water, oil, vinegar, and soda. So clear soda, remember. In each of these, I've already placed 60 mLs of each individual liquid. You're going to take 4 pieces of the steel wool, and we are going to place them into each of the liquids. 2, 3, and 4. Once again, students will let this sit for 24 hours, come back and record their observations. They can monitor these for the next couple days, and we encourage them to do that because some of the changes take a couple days to occur. Also, don't forget that having no changes is still a very valuable data point that students should record. For this, at the end, they want to look at each cup and using evidence from their observations, say whether a physical change has occurred or a chemical change has occurred. For our third part in this activity, students will need to use a plastic bag, Alka-Seltzer tablets, and then use their water again. So what we're going to do is we're going to open up the bag and we're going to measure out 7.5 mLs of water and place it into the bag. Okay. We're going to open up our Alka-Seltzer tablet, place it into the bag, seal it, and close it immediately. Students can break up the tablet to help it dissolve a little faster. We want them to write down and document all of the observations they see, what's going on. And then based off of that, explain, are there any physical or chemical changes occurring? The second part of the activity, they're going to repeat this, except for this time they want to use hot water. They have another bag. They're going to use hot water, put it in, do another effervescent tablet, and this time we really want them to focus on the temperature of the water. They should notice that the hot water starts to turn cold. At the bottom of their page, it then goes into details about exothermic and endothermic reactions. Based on that information, they should be able to determine what reaction occurred in the bag. The second activity in our bag is called reaction rates. Students are going to need the small cups, effervescent tablets, and water. So, our first part is called exploration. In this, we want to take a small cup with 60 mLs of water. We then want to have an effervescent tablet. And students are going to want to use a stopwatch, whether that's on their phone, an actual stopwatch, computer, whatever works best for them. They are trying to determine when the amount of time it takes for the effervescent tablet to dissolve. So when does the reaction stop? How long does that take? So they're going to use their timer, and as soon as the tablet goes into the water, they'll hit start. Now, a great way to think of this is when the tablet is dissolved. If students can't make a determination on their own of when they believe the reaction stopped, a great way to think of it is when the tablet is dissolved. They want to record this time. Part 2 of this activity, we are going to compare temperature to reaction rates. For this one, we will want students to look at room temperature water, cold water, you can put some ice cubes in there to make it extra cold, and hot water. Just get the hottest water from the tap that is safe. So to start off, we're going to have the same setup as we did in part 1. We will take a small cup, and we want to take 60 mLs of room temperature water. The students will then place one effervescent tablet into the water and record the amount of time it takes for the tablet to completely dissolve. They then will take a look at cold water and predict how long they think it will take for a tablet to dissolve in cold water. Run the test, record the data, and compare the results to their prediction. Then they're going to do the same exact thing for hot water. Make sure students predict the amount of time they think it will take before they run the reaction. They will be using this data in part 3. In part 3 of the activity, students will get a chance to graph their data from part 2, analyze that data, and then make a prediction and test 2 new temperatures. As you can see here, we have already graphed the data from part 2 in a bar graph. Based on this data, we are going to ask students how do they think temperature affects reaction time. Then we will have them take a look and predict what do they think the time would be for a tablet if it was placed in cold and room temperature water together, if we mixed the two. Have them write down their prediction. Then, what about if we took room temperature and hot water and mixed it? How long do they think it would take for a tablet to dissolve? They will then run the tests and write down their results. Compare the results to their prediction. The third activity is called chemical bonds. For this activity, students will just need their element cards that are given to them in their student activity packet. From here, we're going to cut out all 15 of the cards. As you can see here, I already have all of my cards cut out. The very first thing we want students to do is to look at the cards and write down what do they notice. The next part, we're going to actually look at the chemical formula for water, H2O. So, students will find an oxygen card. What do they notice about the electrons for oxygen? Now, students will find 2 hydrogen cards. What do they notice about the electrons for hydrogen? Have the students put all of them together. They've officially created a compound. In their compound, how many oxygen cards and how many hydrogen cards do they have? Students should be able to tell you that there are 2 hydrogen cards and 1 oxygen card. From here, we let students know that each card represents an atom of that element. So, how many atoms of oxygen and hydrogen are present in H2O? Based on this, students should be able to say that there are 2 hydrogen atoms and 1 oxygen atom. They should also be able to tell you that the total number of electrons equals 0. We have a small writing underneath that explains that a compound is formed when 2 or more elements form chemical bonds. It goes and explains how the electrons have to add up to 0 and be balanced. Now, using these element cards, any element cards that they want, they can create as many compounds as they would like. They have to remember that the electrons must balance. During that time, they can record every compound they make. Have them keep track of the number of atoms of each element in those compounds, and they can indicate this by writing the number as a subscript. If there is no subscript, it just means that there is one atom. At the end, students should explain if the molecule NaHCO3 could exist based on the balance of electrons. In part 2, chemical reaction, we are going to explore how different atoms of elements rearrange themselves during a chemical reaction. Students should find one Na and one Cl card. When they come together, they form sodium chloride. Students should then explain how NaCl can exist based on what they learned in part 1. Students will then look at the reaction that is written in their student guide. Na plus Cl gives us NaCl. What do they notice about the number of Na atoms on the left side of the arrow and the number of Na atoms on the right side of the arrow? What do they notice about the number of Cl atoms on the left side of the arrow and the number of Cl atoms on the right side of the arrow? Students should hopefully be able to see that there is one Na on each side of the arrow and one Cl on each side of the arrow. We then explain that in a chemical reaction, atoms cannot be created or destroyed. They can only be rearranged. The number of atoms for each element must be the same before and after the reaction. This is called the law of conservation of mass. Now, we ask students to find one sodium card, one chlorine card, 2 hydrogen cards, and 1 oxygen card. They're going to look at 2 separate compounds and how they are combined together. First, they will build HCl and NaOH. Based on what they know about electrons, they should be able to tell you that these 2 compounds can exist. Once again, they will look at the formula and write down the number of atoms for each element. Now they will look at when HCl and NaOH react together. They will be looking at NaCl and H2O. We've determined that NaCl and H2O can exist, and so all they have to do is write down the total number of atoms for each element. The complete chemical reaction will be below. The reactants are on the left and the products are on the right. For the final part, students will explain how the equation supports the law of conservation of matter. The law of conservation of matter, remember, states that the number of atoms for each element must be the same before and after the reaction. The very last piece is to check students' understanding. They are given another equation, and based on their information that they learn, they want to explain how each of the compounds can exist, and then provide evidence that the equation supports the law of conservation of matter. And that is our 8th grade chemistry student activity.